Hello, and welcome to another episode of Plastics Made Simple, the podcast where we break down the complex world of materials science and manufacturing to help you stay informed and ahead of the curve. I'm your host, Vantage, and today we're diving into the fascinating world of thermoplastics and thermoset plastics. These two materials are foundational to so many industries, but their differences can be a bit tricky to navigate. So let's make it simple. Let's start with thermoset plastics. These are the superheroes of durability and heat resistance. Once they go through their curing process and irreversible transformation, they become hard, infusible, and, well, permanent. Think of it like baking a cake. Once it's baked, there's no turning back. Thermoset plastics are processed through methods like injection molding, compression molding, or transfer molding. Their molecular structure is fascinating. During the curing process, heat or radiation triggers a chemical reaction called cross-linking. This creates a three-dimensional network of polymer chains, making the material incredibly rigid and stable. What are some common examples? Epoxy resins, phenolic resins, and polyurethanes. These materials are staples in industries like aerospace, electrical, and appliance manufacturing. In aerospace, for instance, thermoset composites are valued for their strength-to-weight ratio and resistance to corrosion and high temperatures. In electrical applications, their insulating properties and flame resistance are crucial. And in your kitchen, thermoset plastics are hard at work in heat-resistant components of household appliances. But like any material, thermoset plastics come with pros and cons. On the plus side, they're chemically resistant, heat-resistant, and dimensionally stable. However, they're non-recyclable, which can be a drawback in today's sustainability-focused world. Now, let's flip the script and talk about thermoplastics. These are like the chameleons of the plastics world: moldable, remoldable, and recyclable. When heated, thermoplastics become pliable, and when cooled, they solidify. This unique property makes them incredibly versatile. The molecular structure of thermoplastics is made up of long polymer chains without cross-linking. This allows them to be melted and reshaped repeatedly. Some common examples include polyethylene, polypropylene, polystyrene, PVC, and PET. Their applications? Practically everywhere. In the automotive industry, they're used for lightweight yet durable parts like bumpers and dashboards. In packaging, thermoplastics are molded into all kinds of shapes to protect and present products. And in construction, they're integral to pipelines, insulation, and roofing materials. Thermoplastics also have their advantages: recyclability, impact resistance, and cost-effectiveness, to name a few. However, they can soften or deform under high temperatures, which limits their use in certain applications. So, how do these two materials compare when it comes to the environment? Thermoplastics are winners in the recycling department. Their ability to be remolded minimizes waste, aligning with sustainable manufacturing practices. Thermoset plastics, on the other hand, aren't recyclable in the traditional sense, but their durability often leads to longer product lifespans, which can reduce their overall environmental impact. At the end of the day, choosing between thermoplastics and thermoset plastics depends on the specific needs of your project. Whether it's heat resistance, durability, or sustainability, understanding the properties of these materials is key to making the right choice. And that's where companies like Vantage Plastics come in. With expertise in both thermoplastics and thermoset plastics, Vantage Plastics can help you navigate the complexities of material selection and manufacturing. From intricate thermoforming to high-precision injection molding, they've got the tools and knowledge to elevate your projects. Thanks for tuning in to this episode of Plastics Made Simple. If you found this information helpful, be sure to subscribe and share it with your colleagues. And remember, if you need expert guidance, reach out to Vantage Plastics. Until next time, I'm Vantage, helping you turn complex into simple.